Hello friends, this is the solution video for question number 39, chapter 5 HC Verma. The problem statement says, the figure shown a man of mass 60 kg standing on a light weighing machine kept in a box of mass 30 kg. The box is hanging from a pulley fixed to the ceiling through a light rope, the other end of which is held by the man himself. If the man manages to keep the box at rest, what is the weight shown by the machine? What force should he exert on the rope to get his correct weight on the machine? So first of all, we will try to understand this problem. This is the entire system where a man is standing on a weighing machine. So this blue color is the weighing machine and this is the box, and there is a pulley attached to the ceiling and the man trying to pull this rope to stand still. Okay, so obviously there will be a tension force acting on this string T. Okay, so this weighing machine will read the apparent weight of this man. Okay, so first of all we will try to figure out what weight this machine will read, and then we will try to find out the tension required to get the correct weight on the machine. Okay, so first of all we will try to simplify this scenario. Okay, so here the tension T will be applied by the man on the string T. So this rope is same, so the tension applied on this particular part of the rope is also T. Okay, the mass of this box is 30 kg and the mass of the man is 60 kg. Okay, so I'll write it down. Mass of man is 60 kg and mass of box is 30 kg. Okay, so in the first scenario where the man is providing a tension T such that the system is not at all moving, so that means there is no acceleration acting either in the upward direction or in the downward direction. Okay, so the acceleration is 0. So for this particular scenario we can resolve this entire problem as a simple form as there are two tension acting on the upward direction. There are two m1g, which is, say, m1 is the mass of this lift, and m2 and m2g is the mass of the man. So say this is m2 and this is m1. Okay, so using this free body diagram we can write the equation of motion as 2t minus m1 plus m2 times g is equal to 0. So m1 plus m2 into a is 0. Okay, so from this equation we can get the value of t as t is equal to, so m1 is 30 kg, m2 is 60 kg, so 30 plus 60 is 90, 90 into g, so this will become 90g by 2, so that means 45g. Okay, so say this is 1. So the weighing machine will read the apparent weight of the man. So that means the reaction force which is applied by the machine on the man will be the reading of the machine. Okay, so in that case the scenario is like, suppose this is a man and there is a T acting on the upward direction, right? The m2g is acting on the downward direction and there is a reaction force which is N, which is applied by the machine on the man is N. Okay, so from this diagram we can write the equation of motion as T plus N minus mg is equal to 0. So in this case also the man is not at all moving, or the system is not at all moving, so that is why we have written it as 0. Okay, so if I put the value of t from the equation 1 here, so this will become 45g plus n minus, so this is m2g, so m2g is 60g is equal to 0. So this will become n is equal to 15g. So that means the reading of the machine is going to be the 15 kg. So now for the second part, where we have to find out the acceleration and the force applied by the man on the string to get the correct weight of the man. So if this machine will read out the correct weight of the man, then that means the n should be equal to m to g. Okay, so that's because the mass of the man is m2 and the machine will read the correct weight as m2g, so n should equal to m2g. Okay, so in that case, from this diagram only we can write it as t plus n minus mg is equal to, now this machine will read the correct weight when the body or the system will move with an acceleration a. Okay, so in that case it is going to be the m2a, so we'll write m2g here. Okay, so now to get the correct weight on the machine, so n should be equal to m2g, so t plus m2g minus m2g is equal to m2a, so that means t must be equal to m2a. So say this is equation 2. Okay, so one is this and the other one is this equation. Now also from this equation, where the system in the initial problem where the system was at rest, so in that the acceleration was 0, so now the system will move in the upward direction with an acceleration a. So using this equation we can write it as 2t minus m1 plus m2 times g is equal to m1 plus m2 times a. So we first of all we will feed the value of t from the equation 2, so this will become 2 times, so value of m2 is 60 kg, so 60 into a minus m1 plus m2 is 90 times g is equal to again 90 a. So if I put the value of g as 10, so this will become 900, this is 120, so this is 90, so 120a minus 90a is equal to 900. So it is going to be 120a minus 90a is equal to 900. So I took the value of g as 10. Okay, so after solving this, the acceleration will become 30. Now putting the value of a in this equation, the tension T will become 60 into 30, which is equal to 1800 Newton. So this is the T which comes out due to the force applied by the man on the string. So the force applied by the man on the string is 1800 Newton, then only he will get the correct weight on the weighing machine. So this is the solution of this problem.